Today we're working on section 2.1, Introduction to Limits. I'm sure for some of you this is the first time you're seeing limits, so make sure to check out the notes because I put the definitions of the limits in the notes. Those are definitely good to take a look at because there's two-sided limits and one-sided limits and some theorems. And I'll touch on them briefly in these examples, but you'll want to take a look at the full definition. So a limit is where the function is tending to. So they'll give you an x value, and what you want to do is you want to look at what's happening to the function on either side of that x value and see what number the function is getting closer and closer to. At that x value, the function may or may not exist, but what matters is what's happening on either side, what the function is getting closer and closer to on both sides of that x value. So it is important, if it's a two-sided limit, to look at both sides. Both sides have to be tending to the same number. If they're tending to different numbers, then that two-sided limit does not exist. If you're just looking at a one-sided limit, then they'll tell you whether to look at the left side or the right side. So let's look at a couple of examples. I have them all written on the paper for us. In the first example, we're going to use the graph to estimate the indicated limits and function values. And I'll make sure to point out what each of these values are in case you can't see it clearly. This graph is also in the notes, so if you have the notes in front of you, that might help as well. The first couple examples are just the function values, which you should have learned in college algebra, but let's just review it. So remember, whatever number they put inside here is your x value. So they're saying, okay, my x value is 2. What is the y value at that function value? Well, for function values, it has to be a closed circle or a solid line in order to be the function value. For the limits, it doesn't matter if you have an open circle or a closed circle. It doesn't matter if it's included, it's only what's happening close to that x value. But for function values, you have to have a closed circle. So let's go ahead and look at 2 on our x-axis. Well, we have two different choices, but again, it's a function value, so we can't use the open circle, we have to use the closed circle. Well, what is the y value there? The y value there is 2 as well. Okay, do the same thing for this one. They're looking for the function value, and my x value is -3. So I go to -3 on my x-axis, go up to the function. The function value there, or the y value there, is 2. Okay, so that's all you're going to do for your function values. Then let's take a look at some limits. They start off with one-sided limits because you want to look what's happening on both sides to determine the two-sided limit. Okay, you'll know it's a one-sided limit when they have this little negative or positive sign after the number. Well, that's telling you 0 from the left, 0 from the right. Okay, so they want the limit as x goes to 0 from the left of your f of x. Well, this is f, I didn't label it, but this function right here is my f function. Okay, well, I want to go to 0. So my x value 0 is right here. And you want to approach it from the left. So approaching it from the left, we tend to this point right here, which is 2. Well, this one wants x going to 0 from the right. Okay, well, 0's right here. Coming in from the right, we're still approaching 2. So whether we looked from the left or the right, we got to the same number. And you'll see that when you're looking at the graph, if you want to look to the left and the right, and see if they're getting to the same number, they should meet. Whether there's an open circle or a closed circle here, it doesn't matter, but as long as both sides are approaching that same y value. Okay, so that's what they're asking for in part E, the two-sided limit, limit as x goes to 0. It won't ever say two-sided, but when it doesn't have a negative or positive sign right here, they want you to take into account both of the sides, and we said they were both approaching the same number, so that is the limit too. Well, let's take a look at a different point on the graph. The limit as x is going to 2 from the left. Okay, well, 2 is right here. It's where we had two different choices. So you want coming in from the left. Okay, well, coming in from the left, we go to the y value of 1. Doesn't matter that it's an open circle. Coming from the left, we're approaching the y value of 1. Coming from the right, we're approaching the y value of 2. Well, on the left and the right, we got two different values. So when we look at the two-sided limit, that does not exist. Okay, and they put just DNE for does not exist. Okay, so they might not lead you and make you find both the left and the right side of the limits, but they might want you to find a two-sided limit. So make sure you know that you do have to look at the left-hand limit and the right-hand limit in order to determine what the two-sided limit is. So there's another example in your homework. I think you've got two graphs in your homework where you practice finding the limits and the function values off of the graph. So try them out. If you have any trouble, let me know. Okay. And then actually, the limits where they're written out in expressions are the limits that most students like in this section because they give you polynomials and rational functions in this section. And with polynomials and rational functions, you're allowed to just plug in the value to get the limit. Okay, you'll see that in one of the theorems in your notes. Okay, so here we've got a polynomial times another polynomial, which will give you a polynomial. So you're allowed to just plug the value directly in for x. So we get 2 times 2 minus 4, which gives me 2 times negative 2. So I get negative 4 for the limit. Okay, same thing here. This is a rational expression. We've got a polynomial divided by another polynomial, so we can just plug the x value in. We get negative 3 over negative 3 plus 5, which will give me negative 3 over 2. Okay, let's try one more. Here, if we plug in negative 2, we'll get 4. Negative and a negative will give me a positive 2 minus 6 over negative 2 plus 2. Oh, that gives me 0 on the top and 0 on the bottom. Well, that's what's called indeterminate form. Whenever you get 0 over 0, you need to go back and see if you could have simplified your problem before you continue. So we can factor this. We've got a negative 1 in the middle, so that's our sum, and our product is negative 6. So what two numbers multiply and give me negative 6, but when I add them I get negative 1? Well, negative 3 and positive 2. So let me go ahead and factor that out. I've got x plus 2 and x minus 3 over x plus 2 and the x plus 2's cancel. Okay, so really all I'm doing is taking the limit as x goes to -2 of x minus 3. So plug the -2 in for the x, and we get -5. Okay, so try out the homework and let me know if you have any questions.